31. The shadow price in linear programming indicates A. The cost of the objective function, B. The value of an additional unit of a resource, C. The profit of the objective function, D. None of these. B. The value of an additional unit of a resource. 32. The dual price is also known as A. Opportunity cost, B. Reduced cost, C. Shadow price, D. None of these. C. 33. An unbounded solution in linear programming occurs when A. The feasible region is unbounded, B. The objective function has no maximum or minimum, C. Constraints are not properly defined, D. All of the above. D. All of the above. 34. If the coefficient of a slack variable in the objective function is 0, then A. The variable is non-basic, B. The variable is basic, C. The variable is not part of the solution. D. A. The variable is non-basic. 35. The method used to handle a transportation problem with unequal supply and demand is A. Simplex method, B. Modi method, C. Vogel's approximation method, D. Big M method. Answer C. Vogel's approximation method. 36. In the assignment problem, a dummy row or column is added to A. Balance the problem, B. Minimize the objective function, C. Maximize the objective function, D. None of these. A. Balance the problem. 37. In a linear programming problem, the coefficients of the decision variables are called A. Constraints, B. Parameters, C. Coefficients, D. Constants. B. Parameters. 38. The term slack in linear programming refers to A. Unused resources, B. Additional resources, C. Cost savings, D. None of these. A. Unused resources. 39. A constraint that does not affect the feasible region is called A. Active constraint, B. Inactive constraint, C. Redundant constraint, D. None of these. C. Redundant constraint. 40. A feasible solution that satisfies all constraints and optimizes the objective function is called A. Basic feasible solution, B. Optimal solution, C. Non-basic solution, D. Infeasible solution. Optimal solution. 41. The Big M method is used to handle A. Unbounded solutions, B. Artificial variables, C. Multiple objectives, D. None of these. B. Artificial variables. A dual variable in linear programming is associated with A. Each constraint, B. Each decision variable, C. Each objective function, D. None of these. Answer A. Each constraint. 43. The purpose of the Modi method is to A. Find an initial solution, B. Test for optimality, C. Minimize transportation cost, D. Both B and C. D. Both B and C. 44. The condition for optimality in the transportation problem is A. All opportunity costs are non-negative, B. All opportunity costs are 0, C. All allocations are 0, D. None of these. Answer A. All opportunity costs are non-negative. 45. In the simplex method, the pivot column is selected by A. Highest positive value in the objective row, B. Lowest negative value in the objective row, C. Highest negative value in the objective row, D. None of these. C. Highest negative value in the objective row. 46. In the assignment problem, if the number of rows and columns are not equal, we add A. Dummy row or column, B. Additional variables, C. Artificial variables, D. None of these. Answer dummy row or column. 47. The transportation problem is said to be degenerate if A. There are fewer than m plus n minus 1 allocations, B. There are more than m plus n minus 1 allocations, C. All allocations are 0, D. None of these. There are fewer than m plus n minus 1 allocations. 48. The feasible region in a linear programming problem is formed by A. Objective function, B. Constraints, C. Decision variables, D. Slack variables. Answer B. Constraints. 49. The simplex method terminates when A. All values in the objective row are positive, B. All values in the objective row are 0, C. All values in the objective row are non-negative, D. None of these. C. All values in the objective row are non-negative. 50. The concept of duality in linear programming is used to A. Simplify the problem, B. Provide additional insights into the solution, C. Identify optimality conditions, D. All of the above. Answer D. All of the above.